So in order to solve it, you'll need to change the order of integration in order to solve it. Okay, so if you don't believe me that you cannot solve it, so let me show you on the website as well. Okay, here I am at the symbol lab, and I'm pretty sure you guys already know this website. Here's to solve the double integral, and I put my double integral over here. As you guys can see, they also use the change of order of integration to solve this integral, because they were not able to solve it with the given integrals they had. So they had to change it, and as always, the steps are not given how they change it and how did they get the answer as sine 1. So I'm here to show you the steps. Okay, so let's continue. Okay, so how did they even change the order of integration? Okay, so, and you guys know this is Fubini's theorem, that to be able to change the order of integration. Okay, so the first step in here we always have to do is to draw the graph, okay, using the limits of integration that you are given. Okay, so here we have our axes as x and y. So our first equation over here, okay, so since this is dy and dx, so this is dy, so these values belongs to y variable. Okay, so y equals to x and y equals to 1, and at the end we have dx, which means these two values belongs to x variable. Okay, the dx, this belongs to x equals to 1 and x equals to 0. Okay, so once you have the equations, let's go ahead and plot these equations over here. So first we have y equals to x equation. So y equals to x equation is nothing but simply a linear line. Okay, and then y equals to 1. So y equals to 1 is simply a horizontal line over 1. Okay, so then this is our region that we are calculating for. Okay, so this is our region, and we have dx, and always remember that the end the integral that you have, for example, you have dx over here. Okay, so these always have to be constants. Okay, these cannot be equations. Okay, like here you have y equals to x, so these always have to be constant at the end. They cannot be equations, variables. Okay, so now we have x equals to 1 and x equals to 0. So the x values goes from 0 to 1. Okay, so this means that the that our graph belongs in the x region, it belongs from 0 to 1. Okay, now let's go ahead and change the variables. Okay, so to change the variables, we write the same thing. The equation is the same, 2 cosine squared, and now these two are going to be swapped. Okay, so dx goes first and then dy later. So since this is dx first, so which means these have to be x equals to something, right? And then at the end we have dy, which means this, the first one has to be y equals to something, and in order to find this value, this graph is gonna help us do that. Okay, and like I explained before, here it was dx, so these were constant and not equations. So just like that, these are going to be constant and not equations. Okay, so let's go ahead and find this first. Okay, x equals to something, so this means this have to be equation. Okay, so just remember that when you're going in the dx direction first, since here we are going in dx direction first, in the graph we always go from left to right. Okay, if you were going in the dy direction first, okay, then we would go in the top to bottom. Like here you were going in the dy direction, so we went like upwards in the from bottom to top for this equation. Okay, so here in order to go in the dx first, we need to go from left to right. So let's go ahead and go in the graph from left to right, just like that. So this means that we need to know the equation of this graph, the left side of the arrow and the right side of the arrow. And what is the equation of the line? here that you see over here at the left side of the graph. Okay, so this line is nothing but x equals to 0. Okay, and then what about this one? So this one, we drew this line, right? Y equals to x. So the equation of this line is y equals to x. So you cannot write here y equals to x. You need this equation in terms of x. Since y is equals to x, so here the equation of the line in terms of x will be simply x equals to y. Okay, and this is the lower limit and this is the upper limit. Okay, so the x goes from 0 to x equals to y. Okay, next we have dy. So like I said before, since it's dy, so these y values have to be constant. Okay, now look at where the y values goes in this graph. Okay, where is the region of y value? So here, as you guys can see, here the y values goes from 0 to y equals to 1. Okay, from here, right? Y equals to 0 to y equals to 1. So you're not gonna write any equations over here, only the constant. So y equals to 0 to 1, and this completes your order of integration. Now we can easily solve this problem. Okay, so to evaluate this integral, we always go in the inside, we always do the inner integral first and then the outer integral. Okay, so we're evaluating the inner integral from x equals to 0 to x equals to y, and we have 2 cosine of y squared dx first. Okay, let's go ahead and evaluate this. So here okay, so here we are integrating this with respect to dx. Okay, and since we're differentiating with respect to dx, do you guys see over x over here? No, you guys don't see any x over here, which means this whole thing is a constant. Okay, and if you have a constant, you simply put an x in front of it, right? For example, if you have 2 and you're integrating it with respect to dx, so you will simply put an x, right? The derivative of 2 will be the integral of 2 would be 2x, right? So just like that, we have a whole constant over here, and we simply have to put an x in front of it in order to take the integral of it. Now let's evaluate it from x equals to y to x equals to 0. Okay, so we're putting y first and then 0. So every time we see an x over in this equation, we're going to replace it by y. Okay, so let's go ahead and replace this y, and then here we're replacing this x with a 0, so this whole thing is gonna be 0. Okay, so then if you let's go ahead and rearrange this so it looks better. So 2y cosine of y squared. Okay, so this is the answer to the dx, but we still have dy left, remember? Okay, so let's go ahead and complete the dy part, and yeah, you need to write the dy part at each step. Okay, so I always write it at the end because it's a little confusing to keep writing it at each step. Okay, so you can do the same thing. Okay, now we can finally integrate it with respect to dy. Okay, so here every time you see a y, you need to integrate it with dy. So to solve such problem, you'll need to use U-substitution. Okay, why we're using U-substitution? Because in the U-substitution, if you do the U-substitution of this, you're gonna get something like 2y, and you have 2y in here as well. So to be able to cancel out this 2y with this 2y, that's why you're using the U-substitution. Okay, it's simply to cancel out this 2y that you have over here, because you won't be able to integrate this alone by itself. You need to be able to cancel this y over here. Okay, so let's go ahead and use U-substitution for this. Okay, let me put this over here. Okay, U-sub. Okay, so our u, we're going to take this as okay, we're integrating only this part. Okay, and in order to take the u, we're going to take the inside function, which is y squared, and what's the derivative of y squared? It's gonna be 2y and then dx. Okay, and now we can get the dx alone by itself, just like that. Okay, let's get the dx alone by itself. Okay, so for that we need to divide by 2x, and now we got dx by itself. Okay, and now we can integrate this 2y cosine y squared. Okay, and here we have a dx over here. Oops, sorry, not dx, dy, because we're integrating with respect to dy, not dx. I'm sorry, dy, and it's a 2. Don't think it's a d. Okay, so here we have dy, dy. Okay, so since here we have dy over here, right, in the problem, so we can replace this dy with this du over 2y. Okay, so we're gonna replace this y squared with this u, so u cosine of u, and this dy replace it by this thing that we see over here, du over 2y. So let's go ahead and replace this with du over 2y. So now you guys can see we can finally cancel out the 2y and 2y, and we're left with cosine of u du. Now let's go ahead and integrate this cosine of u. So the integral of cosine of u is sine u. Okay, if you don't know how to do this, so let me explain you guys. So the derivative of sine of x is cosine x. Okay, this is the derivative. Okay, the derivative of cosine x is sine is cosine, and the derivative of cosine is negative sine. Okay, and integral is simply the inverse of derivative. Okay, so here if we already have the cosine, the derivative cosine, so what if we undo the cosine? So what do we get by undoing? So if we undo that, we get sine, right? Okay, so this is how I get sine of u. Okay, so I hope that makes sense. Now once you got sine of u, so this is now you can finally replace this sine of u with the u that you substituted with. So now this sine of u can be replaced with the u that you originally substituted. So sine of y squared is what you get as the answer when you apply the u sub. Okay, so the answer to this then is sine of y squared, and now you can go ahead and plug in y equals to 0 and y equals to 1. Okay, now let's go ahead and put 1, and then we will put sine 0. So sine 0 is 0, and you're left with sine of 1, and this is your final answer. And we also got sine of 1 just like symbol F. Okay, so thanks for watching. Bye.